Dear all, I hope this video finds you well. Welcome to the season finale of What Exactly Do You Do? I am so excited that you have followed us through this journey. I have been humbled by the feedback, the responses. I think more importantly, the comments from people who have watched the video and or the videos and the guests' journeys have provided some sort of clarity on their own career paths or even forced us to ask important questions about our own career paths, what we want to do in the long term as well. So I'm so grateful that you followed us this far. And one thing I want you to do is if there is any career path that you'd like us to cover or you like us to invite a guest who has that career, background specifically, do drop it in the comments. And who knows, you see us in season 2. So thank you very much again. All right. On this episode, I have an amazing guest with me. He's going to introduce himself and tell us how we've come to know each other. Welcome, Ene Maku, Ene for short.
Thanks, Jennifer.
How are you?
I'm
How are
fine.
you?
I'm fine.
How are
I
you
hope
doing?
you've saved the best for the last.
Woo! I mean,
I hope so.
we're talking about money here,
Come
so
on. We're not talking about money. We're talking
Okay.
about people's career.
yes.
No money on the table here.
True.
How did I get to know you?
Yes.
You're my friend's friend.
Yes.
Okay. You're my good friend's
Friend.
good friend's wife's best friend.
Yes. So
I don't want to call him my best friend. I want him to feel bad.
thank you for introducing yourself, Enemako or Ene. So before we get into the questions, I like to do something called an icebreaker where we break the ice. So in that basket, just pick a question and answer. It's supposed to be something light to just help us ease into the questions. Yeah.
I hope I'm lucky.
Yeah. What does it say?
If you could create one holiday, what would it be about?
What's one holiday that we do not
We already have a lot of holidays, though.
So you're anti more holidays?
I'm not necessarily anti more holidays. I'm just thinking we have holidays for boys. Okay, we don't have holidays for boys, though.
We do. We have International Day of the Boy Child.
But it's not a holiday.
Oh, okay.
Men's Day, okay. Women's Day.
Even Women's Day is not a holiday.
It's not a holiday, so
yeah.
an holiday per se.
Yes, that we need to actually not go to work.
We have Workers' Day. That's the only day they give to workers. We need another Workers' Day.
Another Workers' Day.
We need 2 Workers' Day per year.
Workers' Day.
I think we need 2 Workers' Day. That's what I would say.
Okay.
One isn't enough to
celebrate
the recognize the workers.
Our input in the economic development.
Okay, let's call it, instead of calling it Workers' Day, let's call it Management Day.
Management.
But we'll rest, we'll not work. You get, so that managers, at least they are celebrated. We thank the companies for what they are doing. The salaries they are paying is not easy, but can we rest today?
Can we rest today? Yes, but those that are just joining in too, they would rest. It's not just for managers to rest.
Of course, when I said Management Day, managers rest on Workers' Day too.
True.
So,
True.
Yeah. We just call it Managers Day. But it's
Day.
For the workers though.
All workers.
Yeah.
And maybe it will be a chance for these people to actually reflect and think, okay, how am I leading my organization?
Perfect.
How do I make it less toxic or more enjoyable? Just to think about it and strategize, because we want to keep more people coming into the workplace.
Yeah.
Right?
Good.
I'm with you.
Yeah. A day to celebrate the leaders of the corporate world.
All right. Great.
All right.
So let's jump right into the questions.
All right, Ali.
So one question I like to ask my guests is, what exactly do you do and how long have you been doing it for?
So I'll say I'm an engineer by training and by experience. Currently, I work as a petroleum economist or an energy economist.
That's why I said there's money involved.
So I've been doing this for almost 10 years. By March next year.
Wow.
It will be 10 years since I started working in the industry.
Wow.
Yeah.
That's amazing.
Thank you.
Well done.
Thank you.
All right. So my leading question would be, did you always know you wanted to do petroleum engineering or you wanted to be an engineer in the oil and gas space? If not, how did you come to realize that, okay, this is something I want to do? So you're going to basically walk us through your journey from secondary school. What was your mindset or your mind frame when you were deciding whether you wanted to do art, science, or commercial, right? And then deciding your university, your course of study as well. So just, take us on that path of any macro from there till now.
Okay. Firstly, I'll say I'm an engineer in the energy industry.
Not oil and gas.
Not just oil and gas, because where I work, we do beyond oil and gas.
Okay.
We are involved in renewables, biofuels, and all of that. So it's beyond oil and gas.
True.
And we can actually transit into to work in different functions and in different business segments.
Okay.
Now, my story, I'll try to make it short or brief.
Okay.
So, as a young child, I wanted to be an aeronautic engineer because it sounded great and it had to do with planes. Of course, it meant I would need to become an engineer of some sort.
Yeah.
Aeronautical engineering wasn't studied in Nigeria then.
Okay.
So it limited my chances of course, studying that was limited.
Okay.
At some point, I opted to go for mechanical engineering. My grades were good enough. I was encouraged to do medicine, but I never really wanted to do medicine. So I took my JAM, got into the uni. Then, just before I got into the uni, I think in my teenage years, if you used to watch all those Sunday night newscasts back in the day where they do this news recap, I've forgotten the title of the program then. NTA, I think 8 to 9 or 9 to 10, the Sunday program. When they started, they used to show some oil platforms with some fires, and I was like, I want to be there. I want to be there. So, and one of the ways to work offshore was maybe to become an engineer. So I always had that in mind. And at some point, applying for JAM, getting into university, I chose to study mechanical engineering. And fortunately for me, in my fourth year, I had the opportunity to intern with an oil service firm.
Okay.
But this type of oil service firm was into EPCI. EPCI is engineering, procurement, construction, and installation.
Okay.
So they were focused, their business was designing and constructing offshore platforms.
Okay.
So imagine a welder who could weld a story building. So they were into constructing offshore platforms, all those jackets you see. So the first day I got to work, I saw a structure as tall as a story building being flipped about with using multiple cranes and all of that. So it was fun. It was glory days for me as an engineer. As a young engineer, I was very interested, curious. Also, they had a project then. It was a floating concrete refurbishment. They were refurbishing the structure because the structure was vandalized back then when you had those days of militancy in the Niger Delta. So I think it was burnt, and they had to reinstall some compressors and all of that
for the oil
for an oil company.
Okay.
For an oil company.
Okay.
So it was a process platform.
Okay.
A process platform is a platform that takes oil from the wells and then tries to treat it, take away the water, take away some impurities. I want to use that word for basic terms. Clean enough, stabilize it, make it transportable in a safe manner, right? So that was what the platform was, and it was clean. So imagine a concrete floating. So all those things made me it wowed me. And I said, okay, this is what I really wanted to do. My uncle also was a subsea engineer. And for subsea engineers, they are focusing, their areas of expertise is helping oil companies install large pipelines and structures in the seabed, on the seabed, sometimes 1,000-meter deep.
Wow.
Something like a Titanic kind of stuff, but not as deep as
I've always wondered how people go, like how we build under the sea. How does that work though?
Yeah, it's you need a lot of interface. You need a lot of engineering and design, advanced design to enable you select the materials that can thrive in such conditions. Because first and foremost, the pressure is a lot. So let me give you an example. For every 10 meters you go, the pressure at some point is like if you are carrying multiple buckets of water on your head. So imagine a pipe sitting at the bottom, carrying thousands of liters of water, pressing it. So that pipe should be strong enough to be able to bear the weight, which we call pressure, and while performing its service, performing the service it was designed to do for a long period of time. So people have to think about it, design the right equipment. Secondly, installing the equipment is also crazy. You need specialized vessels. When I mean vessels, ships that are designed to install, to construct it.
So basically, it's not a human being that is going down.
Yeah, it depends on the depth. It depends on the depth. I think maximum depth humans can go to 400 feet. After that, you can
go.
Yeah, maximum, I think 400 feet. After that, you can go. And for those depths, you don't just go down. You have to be prepared for such dives. Maybe you stay in a chamber, hyperbaric chamber. You stay there. They condition your blood flow for a period so that you walk in that condition. And when you are done, you are gradually depressurized. Else, imagine if you walk under high pressure and you are just released into this atmosphere. You'll just be like a balloon who was quickly deflated. Just a poof. So some people die. So so not some people, some animals could die. Take for example, if you bring a fish from underwater, deep sea fish or deep sea animal to the surface rapidly, they can blow up. Yeah, because of the huge depressurization. So all those things are unique. And it makes it special. So you need special skill sets, specialized knowledge to be able to perform those operations. So back to my story.
Yes, your internship.
So I had this experience quite early where I got to know some of this stuff. I was exposed to that. I even learned how to fly an ROV.
What's an ROV?
A remotely operated vehicle. So if you remember in Titanic, the equipment which went down into the sea to discover or to claim the picture of Jack's girlfriend.
Rose. Yes.
Everybody remembers Jack.
Jack Rose.
So that equipment is called a remotely operated vehicle. So from the surface, you can operate it like a video game, while it's like a robot, right? So I learned all of those on the side. So during my internship, it was purely on design. I was focused on design. I was also learning how fabrication for large scale equipment and parts were made, and how they were transported for installation. Then I returned back to school, finished my master's degree, and finished my BSc.
So your BSc was in what?
Mechanical engineering.
Okay.
And then during service, I had the opportunity of gaining a scholarship to study petroleum engineering and project development.
Wow.
Yeah, so petroleum engineering is this discipline focused on identifying means to exploit and produce oil and gas from the subsurface under the ground. While the project development focuses mostly on identifying designing the best concepts or ideas or strategies required to produce these assets, to enable you maximize the resource in the ground, or while also ensuring that it's the most economically viable option, right? So I had that training, and after that, oil crash. We had the oil crash of 2015, so we didn't have a lot of jobs in the country because we also had a recession. So within that space, within that period, I worked for a downstream company.
Before we get to downstream, I don't think we've spoken much about that scholarship and where you did the master's. So in case there's anybody that wants to apply, I'm not even sure, does that scholarship opportunity still exist?
It does. So I had my scholarship was the Total Energy Scholarship to study at the Institute of Petroleum Studies.
And you applied for it?
I applied for it.
Okay.
So it exists. I think annually you should check their website, Institute of Petroleum, and is now Petroleum and Energy Studies.
Okay, no more project development.
No. The name of the institute used to be Institute of Petroleum Studies.
Institute of Petroleum Studies.
But now Institute of Petroleum and Energy Studies, because of course we are becoming more diverse.
Yes.
And
yes. So that's the name of the institute where you do the master's.
Yes.
So it's not in Nigeria.
It's in Nigeria, yeah.
Where?
So it's the school is a partnership between the French Petroleum Institute and the University of Port Harcourt.
Okay.
Yeah, the faculty consists of 40% IFP lecturers, 40% of Nigerian lecturers, not just limited to the University of Port Harcourt, and 20% industry lecturers, so people from different companies, Total Energies, Ajib, Shell, and all of those companies.
How long is the master's for?
It's usually for 12 months or slightly above 12 months. Yeah.
Okay, so in Port Harcourt, and people can
then
still apply. Yeah. Okay.
So
do you need to have an engineering background? Obviously. Obviously, right? But any type of engineering, or do you remember what skills they're looking for, what background or criteria that makes you fit for the scholarship?
I think I have seen engineers from diverse backgrounds compete for opportunities at the IPS and get them. So I won't limit anyone. I'll rather say try if you're really interested. And then go through the process. They have a very good selection process. And if they see your aptitude and your interests and it fits into it fits into what they think they want, definitely you'll be selected. Yeah, you should be selected.
One more thing. If let's say someone says, okay, maybe I'm not going to apply for the scholarship, I can just apply for masters to the institute directly and pay. Does that work? Or you have to be
the institute, from what I hear, the institute has multiple centers. If I can recall, they have multiple centers. One in subsea engineering, others in petroleum geology, occupational health and safety, and all of that. So there are some of those programs could be self-sponsored, while others are purely sponsored. So if you go to the website and make some inquiry, you'll get all the information required.
Yeah. We'll put the website in the description link below for you to access it. Okay.
Right.
So sorry
you have
for
to pay us for this. Although that's why we're here. I'm a benefactor, so of course, definitely.
That's why we're here. That's why we're here.
All right.
So if we track back, so we spoke about your internship, then your master's, and how it coincided with the recession.
Man.
So there were no job opportunities like that for you. So how did you now?
So the oil crash with the Avengers attack on upstream assets. So the country was in a recession got into a recession, I think, in 2016. I graduated November 2015, so that period was a bit tough. I think for about a year plus or more. There were a few very limited job opportunities.
How did you
fortunately for me,
Yeah.
I got the opportunity to work in the downstream with a petroleum product supply company.
Okay. So downstream, then there's upstream, there's midstream.
Perfect. We'll get there.
We'll get there. All right.
Yeah. So I did that. The company was involved in a project. They were trying to build a petroleum products terminal. So I learned how to do pre-project planning, identify the best concepts. Okay. Unfortunately for the company, they became bankrupt.
Wow.
Just
because of the recession.
Yeah, partly contributed.
Partly?
Yeah,
Okay.
and then it contributed to it. And so I left, and then I got an opportunity to work as a design engineer with a major design company. I learned how to design mechanical equipment, design and select mechanical equipment for oil and gas processing, right?
Can you disclose the name of the company though? I mean, you're not working there anymore.
I'm not working there, but okay. With Delta Freak.
Delta Freak.
Delta Freak Engineering Limited.
Okay.
Yes.
Okay.
So I did that.
Okay.
And then I did that for a year. Then I worked with a sister company. They were into offshore construction. So
Okay.
Delta Freak was into design. The sister company was into offshore construction. I won't disclose the name.
No, it's fine.
Offshore construction. Offshore construction.
Yeah.
So I learned how to, after designing, of course, install, construct, and instruct. When we say construction, mostly welding, fabrication, joining parts, and all of that. Yeah.
Okay.
So offshore construction, did it for another year. I also learned hookup and commissioning.
What's that?
Hookup and commission, not hookup. Hookup and commission.
Please help us explain what it means.
So hookup and commissioning is, hookup is trying to connect when you're trying to connect systems, right? Systems together. So components are built. Systems. Yeah, components are built isolatedly, like in units, in modules. Yeah, in modules. Right. And then after that, you need to connect them, ensure that they are synchronized, they work perfectly, right? Commissioning is ensuring that these components are preserved first and foremost.
Okay.
And made available and are able to work effectively when starts.
Okay.
When you press, the day you press the start button, you want to ensure that the system starts.
Okay.
Right. So it's like building your house and setting up.
Yeah.
So hookup and commission is like setting up, ensuring that the movers don't break a plate, ensuring everything is organized, everything is properly preserved.
Yeah.
Right.
Yeah.
And then the day you turn on the switch on the socket, the whole light comes up without spark, without fire, and all of that. Yeah, so it requires a lot of systematic planning and integration. Yeah, you do a lot of testing. You test the component, you test the module, you test the subsystem, you test the entire system. Following specific guidelines and procedures. Okay. So I did that for a while.
Okay.
Then I got into an oil producing company.
Okay.
At this time around, I was drilling. Drilling is well construction.
Well construction.
Yeah. So for drilling, what you're trying to do is you're trying to put a hole in the ground in a safe manner to ensure that you can produce the oil or gas or hydrocarbon. We call them hydrocarbon. Okay. Oil or gas is hydrocarbon to ensure that you can produce the hydrocarbon safely and maximize the resource right in the ground. Okay. So that will require you sizing the tubings, the casing, designing the selecting the kind of rig. The rig is the equipment that actually puts the hole in the ground, right? To enable, you have to select the right rig because the rig should be able to drill to depth. So if you're going 10,000 feet below the ground, you need a rig. You need a rig that can do so. Certain rigs, their capacity might just be to drill 6,000 feet, right? Others have the capacity to go 15,000 feet, you see. So all those things you need to consider the size of the hole you're going to drill and all of that. So I did that for another almost 2 years.
Okay.
Yeah, making a total of like 4 years before transiting into supply chain.
Supply chain, okay.
So while working in the supply chain space, I was a contract engineer. I was putting in place contracts for oil and gas drilling. So it related with my previous role.
Okay.
Oil and gas drilling, putting contracts in place for technical logistics like vessels, offshore vessels that supply products to the platforms, purchasing equipment spares required for the efficient functioning of process plants and equipment.
Okay.
Process plants, yeah. And then what else again? So I did all of that for like 3 years, right? Then I moved into energy economics, which I currently do.
Okay.
So that entails assessing the economic viability of projects, oil and gas projects. So there's a nice concept developed by the petroleum engineers.
Okay.
Right?
Yeah.
Remember that?
Yeah.
And they need to test if it makes sense, right? If it's economically viable. So after they've spent a lot of time identifying optimal concepts, you have to then test if the concepts are economically viable and also see how they contribute to the bottom line
of the company. Okay.
And then we also assess, we also support the company in the long-term business planning. So the business planning exercises, you want to see how the overall project currently existing within the company's portfolio are performing and identify or run sensitivities to see how those projects could be optimized to make them to maximize output and, of course, improve efficiencies.
Yeah.
So we support with all of that and other things we do.
Yeah.
Yeah. So
I mean, you've had a very rich career. You're fortunate to have experienced almost all of it, from downstream to designing and drilling engineer to supply chain, and then now you're an economist and energy economist as well. So I would say that you have like a very broad experience in the energy
industry. Yes,
energy. I don't want to say oil and gas energy.
Thank you. All right, that works.
Yes. So, I mean, we've said a lot of things, but one thing I want our guests to get a clear understanding of is the different, sectors in oil and gas. I know that you have upstream, you have midstream and downstream. So if you could just throw some light on what those different industries are, and if do you need to study anything specifically to get into either one of them, that kind of thing, and what basically to expect, what are the functions that are possible. So if you're in downstream, obviously I know that I cannot drill a well, so how am I contributing with my engineering, background to that sector in that way? So
okay, so I will start with, from a value chain perspective, upstream is where things begin from, kind of. Then midstream is where you do some transportation, logistics, and then downstream is where the product, maybe a finished product, right, gets to the customer. However, as you know, demand for energy comes from the customer. The more cars you buy, the more gadgets you have in your apartment, the more lighting you put in your house, right? The more economic activity, the more economic activities we perform as a society, the more energy we
require. Power
the more kids we have, the more salaries you earn, your lifestyle changes. You want grilled chicken, no more roasted chicken. So you need more power. So everything actually comes from comes from the consumer. They dictate supply. They dictate demand, rather.
And maybe that's why during COVID, when the world literally shut down, companies were not processing, people obviously were consuming lights in our houses, but the industries that had shut down,
we're consuming less.
They're consuming less, and so that initially caused the price of oil to come down.
Perfect. Okay. So now, starting from that, I would have loved to start from upstream, but either way, let's see.
No, we can start from upstream. Let's start from upstream.
Let's start from upstream. Yes, okay, I wanted to start from downstream, but upstream is fine.
So no, let's start where you want to start from.
Let me not confuse you. Let's start from upstream. Okay, upstream.
All right.
Upstream. Mm-hmm. Upstream is mostly the activities in the upstream are exploration, production, and maybe exploration, development, and production, right?
So upstream is not like on land, it's on sea.
Because sometimes no. It can. That's onshore, offshore.
Oh, okay.
Two different concepts.
Got it.
Upstream is mostly production.
Yeah.
Extraction, it deals with the extraction of the raw materials. In our case, it deals with the extraction, exploration for oil and development.
Okay.
When you explore, you check if there's oil in that location. If you find hydrocarbons, that's oil and gas.
Yeah.
You then explore. You then appraise to check if it's commerciable, if it's sizable enough.
Okay.
Then you develop it. Develop means all those stuff I mentioned earlier, all those offshore structures, you put them in place.
Okay.
You lay your pipeline.
Okay.
You bring an FPSO.
What's FPSO?
A floating production storage.
Okay.
And it's like a vessel that processes oil and gas.
Okay.
Yeah.
Okay.
Yeah, so you bring all those things in place to enable you produce what you have discovered, the resource you've discovered in the ground, right?
Yeah.
And that's the upstream. The midstream focuses on transporting the processed hydrocarbons, right?
Okay.
Transporting it. So you have LNG, liquefied natural gas.
Okay.
You have pipelines within that group, oil tankers that carry oil from offshore, for example, to refineries.
Okay.
Right.
Okay.
Oil terminals where oils are collected, are received from different oil production plants.
Okay.
Right. So all those assets, you find them within the midstream. So it's like collection or receiving of
what has
hydrocarbon
processed,
right? Not processed, receiving of the hydrocarbon from the production plants, right?
Okay.
Receiving it and distributing it to refineries.
Who would then
process it, right? Yeah. So the midstream is mostly transportation, logistics, and all of that. Now the downstream. In downstream, you have refining and distribution to the end users. So, take for example, we now have a functioning refinery in Nigeria.
Dangote refinery.
So, they receive crude
from the midstream
Okay. Midstream through midstream systems, right? And then they process this crude, refine this crude from crude oil.
Yeah.
You get petrol, you get kerosene, you get diesel, you get tar.
Not of Vaseline.
Paraffin wax.
Okay.
All of those stuff.
Yes.
You have a lot of petrochemicals. Petrochemicals used to make clothes, watches, TV, camera lenses, and all of that.
To make camera lenses too.
Everything.
Wow.
With camera lenses, if it's a glass, of course it's not. Or if it's plastic.
Yeah.
So most plastics are byproduct of petrochemical of refined hydrocarbon rather.
Okay.
Yeah. So they are product from petrochemical industry. From the name petrochemical.
Petrochemicals.
So chemicals from petroleum processes.
Yeah.
Yeah.
Okay.
Petroleum inputs or feedstock.
Yeah.
So that's your downstream. In the downstream also you have your marketing and your retail, right? So the fuel stations you see around,
fuel, diesel,
downstream, all of that.
Okay.
All of that.
Okay.
So downstream interface with the customers, those are the people you see.
Yeah.
But those persons require products from the refinery, right? If it's LPG, is your cooking gas, right? If it's LPG, you need to go to a gas plant, but those gas plants have to source their product from a processing plant that converts gas, which is vapor, right? In a vaporized state, change it to liquid, which is then stored in a bottle, for example. So those stops happen in the downstream, right? Then the midstream focuses on the transportation of the extracted hydrocarbon to the refiners,
to those
or the processing plants, right? So while the upstream focuses on extracting and then stabilizing, removing impurities, but it's still the original state is still maintained. There's no change in states.
Okay,
you get the point. There's no change in states. Yeah. So that's what really happens in that space. And now, with respect to the participants, right? So in the upstream space, you have oil producing companies, right? Oil producing companies. Oil producing companies focused on extracting oil from the ground, exploring, extracting, appraising, developing oil fields or hydrocarbon fields. Now, those companies can be classified into international oil companies.
That's why you have IOCs.
IOCs are oil companies that are in multiple countries. And most likely, they are also players in the midstream and in the downstream. They are quite vertically integrated, right? Whereas you also have independent. Those ones are just international companies, but they are not so vertically integrated, right? And then you have local oil companies. Like I don't want to mention names. Oil companies.
Names so that people can relate.
Seplat, Towando, and all of those companies.
And then the IOCs will be Chevron, Total
Energies,
and
all of that. ENI, known as AGP in Nigeria.
Okay.
That's Eni.
Eni, yes.
All right.
So those are oil producers, those are participants.
Oil
and that's local and international.
Local, international, independent, and all of that. Then you have state-owned oil companies.
That's your NNPC,
example. NNPC, Saudi Aramco, ADNOC, that's Abu Dhabi National Oil Company. Petrobras, that's Brazil, the Brazilian petroleum company, and all of that. And then, so those are the major oil producing. Let's call them oil producers.
Producing participants.
Oil producers, right? Then you have other people who support them, like oil service companies. So these oil companies, yes, they want to extract oil from the ground. They want to produce these hydrocarbons. However, they need advanced technology. And as an organization, you can't be focused on developing technologies while at the same time trying to produce and sell a product. So you need organizations or entities who will be responsible for advancing the technology required to extract
these hydrocarbons,
right? So those are oil service companies. For example, the company I worked in who were competent enough to flip story buildings, kind of like structures. They provide services. So an oil company wants to develop an asset offshore. It requires a platform. And those kind of companies will be able to do so. So a certain drilling technology requires specialized skill set, like the Schlumbergers, the Halliburton, the I forgot this company. I can't forget them.
You mentioned Cranborg.
No. Cranborg is construction.
Yeah.
Schlumberger, Halliburton, and it's an American company.
Do they operate in Nigeria as well?
But Baker Hughes.
Hughes.
Oh my God. It will have been a big embarrassment.
No.
Baker Hughes.
Baker Hughes. BAKERHUGHES.
Perfect. Yeah, Baker Hughes.
Okay, I've seen their names before.
Weatherford, those are the top. Then we have a lot of great Nigerian oil service companies.
Like which
Oil
ones?
Data.
Can you say again?
Oil Data.
Oil Data. I've never heard of them
Oil
before.
Data, AOS Oil.
Okay.
Yeah, lots of big companies.
That's interesting.
Yeah.
Okay.
Yeah, so
do they also provide vessels to ship or is another set of people?
Different service providers.
Okay.
So those are marine contractors.
That's what I was trying to remember.
Contractors, they provide a lot of vessels. Yeah, different size, different types of vessels. Then you also have rig contractors who provide rigs. You also have chemical product contractors. There are lots of services. In fact, catering services.
Yeah, food as well.
Because imagine 200 people working offshore on a particular plant. They need to eat every day.
Yes.
It needs to be catered for.
Yeah.
It's like managing a mini hotel. A major hotel offshore. So people are into that.
Yeah.
So you don't need to be technically skilled to do so.
To do that.
But you need to be able to operate safely. And you need to be able to work, have a very good supply chain system. Supply chain system to manage all the logistics requirements for that.
Okay.
Yeah. So you have lots of service provider, even healthcare service provider. You have financial services provider, because these companies need to be able to move money.
Okay.
To change currencies and all of that. So
manage all their payments too.
Insurance, manage risk.
The
risk oil companies carry is so significant that sometimes you require multiple insurance companies to partner to be able to bear those risks, right? So it's big.
It's quite robust.
In fact, when you for major oil projects, when major oil projects are undertaken in a country, it's almost like hosting a small World Cup because of the trickle down effects it has on the economy. Yeah, so these are projects, and we have lots of an ecosystem supporting the oil producers, right?
Yeah.
Okay, so with that you can see you get some perspective on you get some perspective of what is actually done there. The skill sets, right? So in the upstream,
before we go to skill sets, the participants are oil producers and oil service companies.
Oil producers, oil service companies.
Okay.
You have regulators too. The government, like your NUPRC.
Okay.
For the midstream, you have the NMDPRA, right? They are midstream regulators, midstream and downstream regulators, right? You have other agency, safety agencies to ensure that the operations are performed safely and the environment is also protected.
Yeah.
You have spill agencies, National Oil Spill Response Agency. So those agencies mostly act as regulators, ensuring that the oil companies and also the service companies operate sustainably, right, and responsibly.
We've covered a lot, right? So we've spoken about the participants, we've spoken about the oil producers, independent, international, local. We've even given examples, and then we've spoken about the oil producers as well, from catering down to health and safety, down to those that construct the rigs and platforms and all of that. And then we spoke about regulators as well, right? So what skills, because our audience mostly are those in school, either in uni or in secondary school, and they're like, okay, what skills do I require, if any, to be able to work in these industries or these sectors or subsectors that you've mentioned, really?
Okay, so generally, since we are a real sector, the core skills required to work in the oil and gas industry will be your technical skills, engineering skills. However, I said earlier that the industry is quite big, is large.
Yes.
And we have non-financial, non-technical skills. Non-technical skills are required.
Yeah.
Like, for example, for finance, we need finance specialists.
So you can hire me.
Definitely to come and manage investment analysis. you need auditors. You need doctors, occupational health physicians.
That's true.
You need nurses, offshore nurses. You need
even the computer IT people as well.
In fact,
lawyers.
my company,
yes,
the company I work for,
yes,
has the largest supercomputer in our industry.
What does that mean in terms of?
Like in terms of, we use it for processing, to develop super models required to identify how to produce oil from the ground. So it's massive. We also use it to design the best ways to manage carbon capturing and carbon there's a word we use, carbon storage, for our carbon capturing and storage. And storage
so you need
systems,
a lot of IT people.
So you need IT, super smart IT guys, AI specialists.
AI too?
Yes. And in fact, we need content creator.
Are you serious?
Yes. If you go online and see the kind of content companies create, you will see that they are exceptional and they are actually made by highly skilled content creators. The kind of videos we shoot, the audios and all of that. So it's an open industry.
Okay.
So long as you have so long as you're good at what you do, your skills, and you are able to provide the required service on time, there's a chance that your service will be needed and you can work
in the energy industry.
In the energy industry. So of course the core skills are technical.
Yeah.
Then you have a lot of support functions, supply chain, all of that.
Yeah.
So
yeah, that's interesting.
Yeah. Now back to that, but from an engineering perspective, if I'm speaking to the engineering student at school, petroleum engineering, mechanical engineers, they design and select equipment, process chemical engineers, they design processes, civil engineers, they design structures, buildings, the offshore platforms I mentioned, subsea engineers, what other electrical engineers, instrumentation, mechatronics engineer, or support instrumentation, process safety engineers. So if you have an engineering skill set, perfect. Material scientists, analytical chemists, because we have labs, we design chemical we design fluid systems to support different aspects of our operations.
So chemical engineers too are
chemical engineers, chemists, physicists,
that's a
computer scientists,
that's a broad range.
Geologists,
how could I have forgotten geologists? Geologists,
geoscientists. Geologists help us find where the accumulations are, where the resources are.
So are they the ones that usually do the initial feasibility to see that there is oil somewhere before you now start, digging and exploring?
Yeah, they work with geologists and geoscientists. They work together to. In fact, geologists are now considered geoscientists because it's a broad discipline, right?
Okay.
They work together to identify the accumulations. Yes.
Okay.
Before an attempt is made at drilling, exploring first.
Okay.
Yeah.
Okay.
And then developing the resource.
All right.
Yeah. So it's broad. Lots of skill sets are required.
Yeah.
For entry-level opportunities, all you just need to do is identify when openings are there, when adverts are made, check if your skill set is required and apply for it. It doesn't have to be. Take for example, if you studied metallurgy and there are opportunities that closely relate to what you studied, you could apply for it.
Okay.
Right? Not necessarily, it doesn't have to be an exact title.
Okay.
So don't limit yourself.
Yeah.
So long as you have the requisite skill sets.
Yeah.
And you can easily transit to it. Right? Take for example, my first degree was mechanical engineering.
Yeah.
My master's degree was in petroleum engineering.
Yes.
You see, so it's something, so long as you have that technical acumen, you could actually learn.
Yeah.
And provide you're able to provide service to the companies you work in.
Great.
Yeah.
Okay. So my next question, I'm thinking more of the future.
Okay.
Right. So if I study mechanical engineering or pet engineering, whatever it is, with the way the world is advancing and we have a lot of talks on climate change, I know that several companies are now positioning themselves to also, deal in the renewables energy space and all of that. So I'm just thinking your thoughts, or for long-term perspective thinking, for those that are pursuing, these degrees right now, should they be worried that the rise of climate change and transitioning to renewable energy would sort of affect what they're currently studying in school? Or how do they position themselves so that they are also able to be fluid with these changes, such that their degrees are relevant, but they're also able to, be key, players in renewable energy or whatever it is? What do you think? Yeah.
When you say their industries will be relevant, I think most industries over time have transformed, right?
Yeah.
Industries transform based on technology, based on needs and all of that.
Yeah.
So as a student, if you're entering any industry, there's a high chance your skills, your knowledge will flow, will change, will be transformed as the industry transforms.
Yeah.
Take for example, 30 years ago, oil was explored using paper maps. The scientists didn't, the geologists, the geoscientists didn't need a computer system to make models.
Yeah.
Right? Just the foundational principles, and they were able to do what they needed to do. Over time, you now need advanced skill sets, right? Which has grown based on the need of the industry, right?
Yeah.
So knowledge grows, knowledge expands,
Yeah.
and so an individual shouldn't necessarily be worried about that. Speaking on broader terms, the industry in itself is accommodating, is adapting to the different needs, right? When it comes to the future of energy, I don't want to speak just necessarily, I don't want to limit myself to climate change. I'll come back to that. We see that the world would the energy needs of the future would be a mix rather than a specific need, right? So the world is not going to solely depend on renewables, right?
Yeah.
You'll still have a mix of hydrocarbon, fossil fuels.
Yeah.
You still have hydrothermal, geothermal, hydropower, what do you call it? Hydropower, yeah.
Yeah, the one that
Hydropower,
uses,
yeah,
hydro.
hydropower.
What of
Yeah.
wind? Is wind under?
Wind is considered renewables.
Okay,
Yeah.
okay.
So hydro is also considered renewables because you don't necessarily deplete the resource, right?
What is hydro? What is an example of hydro?
Kanji Dam.
Kanji Dam. Is that not water?
Hydroelectric.
Is that not water?
Yes, it's water.
So
it's hydro. Hydro is water.
Oh.
Sorry. You want to cut it?
No, it's fine. I mean,
okay.
Yeah.
So hydroelectric, as I mentioned earlier, hydroelectric, solar, biofuels,
wind,
You're still going to need hydrocarbons, fossil fuels in the future. So it's going to be a mix. What the world is what the industry is currently focusing on right now is, first of all, reducing its emission by producing cleaner hydrocarbons. Not all oil molecules are equal in terms of the amount of CO2 they release when produced per production, right? So for each molecule of hydrocarbon you produce from a resource, you might emit more CO2 depending on the type of resource, right? Or depending on how clean the resource is. So what most companies are doing currently is to ensure that they only produce or develop resources which will emit less, or that emit less CO2 compared to other resources.
Like, for example?
Okay.
Which resource emits more? Which resource emits less?
Coal and tar sand. So you can produce hydrocarbon from muddy oil. Let me use the word, right? Whereas you can also produce crude oil from very light oil that flows freely.
Okay.
Right? You don't need to do a lot of processing.
Okay.
You don't need to do a lot of cleaning.
Yeah.
Right?
So that reduces emission.
It reduces emission.
Okay.
So that's one way.
Yeah.
Another way is to limit the emissions in the plants by monitoring leakages from the components. Before now, maybe emphasis was not made on ensuring that the plant had reduces the leaks that came from component parts.
Okay.
Imagine if you had multiple flanges or joints, and before now you didn't care if gas was just seeping slightly from them, but right now you are concerned about such, and you try to ensure your flanges are always tight. You don't tighten to ensure you don't have you don't have a lot of emissions. You also consider the amount of energy you consume in processing the hydrocarbon, right? You want to ensure that if the molecules are cleaner, you require less resources to do so. Secondly, you want to be able to use renewable energy in processing or in treating the hydrocarbon, for example, you bring from the ground. By using imagine you are using your plant is powered by solar or wind rather than by fuel. So you emit less. You get the point. So there's a kind of integration and harmony that these companies are trying to create to ensure there's emission is lowered, right? And there's also a lot of emphasis on energy efficiency, where people are encouraged to use less power, turn off your light, switch off your light when you're not using it, reduce your refrigerator, increase the temperature of your refrigerator. Your refrigerator doesn't need to run at minus 27 all night when you're not opening the fridge, because once you open the fridge in the morning, all the effort made is lost, right? You can actually preserve your food at -5 rather than -14. You get the point.
Noted.
So all those little stuff actually matter. When we do all of those, you realize that we jointly together reduce the emissions we create. And then what else again? So there are lots of efforts made by companies to actually reduce emission. And then they are also working. There's this concept called the net zero. Where at the end of the day, your efforts, the total emission you release is zero. Not because you're not releasing emission, but you are compensating for it.
How are you compensating?
Take, for example, you plant more trees to capture more CO2, right? You also you intentionally capture CO2 and store them in the ground.
You can store CO2 in the ground?
Yes.
What does that do?
I'll come
to the ground. Does it have any negative impact?
No negative impact. So old oil wells, oil reserves that have been depleted, you replace them with CO2, for example, right? Old cavities, caves, all of that, you could do so. And it reduces the amount of CO2, right? At the end of the day, your operations could be net zero or even net negative right? Depending on how effective you are and how interested you are in fighting climate change, right? So a lot of companies right now are really focused on that. And it also relates with the question you asked about what's the future for young engineers coming, what it looks like. Take, for example, a reservoir engineer whose job was to optimally produce oil from the ground by studying how oil flows through the ground and optimizing it, can now use that knowledge, apply that knowledge in injecting CO2 to the ground for storage. You get the point.
Yeah.
So the knowledge is not lost, right?
Yeah.
So reservoir engineers could be good carbon capture storage engineers, right?
Yeah.
Geoscientists would need to identify, just as they identified where oil or hydrocarbons were located. They can also identify optimal storage for CO2 storage.
Yeah.
You get the point?
Yeah, I
optimal
do.
Reservoirs for CO2 storage.
Yeah.
You see? So
no cause for alarm.
No cause for alarm per se. And then the fact that the future is going to be an energy mix. So companies, countries who have a lot of hydrocarbon resource and who can produce at very low price or at lower prices will most likely continue producing until it's no longer economically viable to produce.
True.
And so there is a high chance. I don't want to say 100% chance that oil production will continue.
Yeah.
Oil production will continue.
Yeah.
And the skills, the requisite skills, the relevant skills, those skills will still be relevant in the future.
Yeah.
Right.
Just need to be able to adapt, adjust,
grow, upskill.
Very important. That, yes. And I mean, I feel like even companies, they train their staff. Like once you get in as well, they also train to align with what's happening in the industry.
So there's this concept called just transition.
Okay.
So the concept of just transition is to ensure that people are not left behind when the industry or when the world generally moves from fossil fuels, right, to other energy sources, right, other cleaner energy sources. And because at the end of the day, the purpose of energy generation is to better the lives of people.
True.
And when you leave people behind, you actually are not making them bettering their lives.
Yeah.
So what you do is to ensure that when you are transiting from fossil fuel to other sources, you also help them upskill to enable them transit.
Yes.
That way, no one is left behind. Take, for example, a former refining plant, right? A refinery could be modified or renovated. What word would I use? Refurbish. No, refurbish is to repair. Could be transformed to a biofuel plant. Right? Where you process biofuel, right? Because you already have a system. You just need to change the process flow and the flow of processes. And then people will be able to operate the same system, because what they just need is to they are engineers. They just need to understand the flow of the process, the systems, what they needed, how to control the process, and then they are good to go. So plants can be in the future. Refineries could be repurposed for other uses. Take for so long as you are an eternal optimist, you should be able to find something doing. Even if oil is even if the world fully transits from oil, which is a very, very rare scenario. So it's gonna always be a mix.
Yeah. Great. I think that we've done justice. We have explained so many concepts. So just light question, very, very light.
Okay.
How busy, or what is the day-to-day life of an oil and gas or energy economist in this case? I mean, in finance, for example, we know that there are some places that the industries are very time demanding. You have your investment banking, even consulting. I mean, so many places, depends, right? But for oil and gas, I know that I will answer the question and say it can be lucrative depending on what part you find yourself. If I'm wrong, then you can say otherwise. But if I'm not wrong, how time demanding is it?
So always remember that money chases value. Yeah. Money chases efforts.
Yeah.
Somehow. So if you feel it's lucrative, then people are really giving their best.
Yeah.
Oil and gas operations are continuous.
Yeah.
So 24/7, especially on site. So if you're on site as an engineer, you most likely be working in shifts, and then you will be required to take time off to align based on labor conventions and all of that, right?
Yeah.
At the office, depending on your work schedule, and you could have a normal 9 to 5.
Yeah.
Or there are days where you need to really put in a lot of work, and they are seasonal. So general life of an oil and gas economist is no different from that of an investment banker. Maybe not so, but sometimes it could be as demanding as that. And so there's not much difference. Yeah, it's just that you're doing it for a different purpose. Yeah.
Great.
Yeah,
Great.
company.
I would like to end with one more question. So, what are the growth prospects for an engineer in the oil and gas or energy industry? What are the growth prospects? So, for example, if you're working in consulting, you know that you get to partner at some point.
Okay.
Yes. So, for oil and gas, what are growth prospects? And it's a 2-in-1 question. Then, second question would be, where do you see yourself in the next 30 years? What impact do you want to make? It may not be in energy, it may be wherever, but it would be nice to know your thoughts on that. So the growth prospects, and for you specifically, where do you see yourself in the next 30 years?
I've done 10 years. 30 years I'll be retired.
You'll be retired. But what impact do you think you want to have made as well?
I just did that.
Yeah.
In 30 years, I'll be retired.
Okay.
However, I'll answer your first question.
Okay.
So as an engineer, we're generally trained to we have strong aptitude. We are trained to understand systems and replicate them, understand basic principles of physics, chemistry, natural science, basic natural principles, and then replicate them, develop systems that apply these principles. So because of that training, we naturally are able to understand complex stuff, complex matters or subjects, and within a short time we can actually become very good or proficient at new concepts or new disciplines in new disciplines. So for an engineer, I don't want to say oil and gas engineer, you could grow deep in your specialty, grow to become the chief engineer, help in the development of methods, best practices, right, required to safely perform operations. Or you could at some point transit into either non-engineering, non-technical area, general management, where you focused on helping company maximize value through managing personnel resources to ensure the objectives of the company are met. Objectives of the company are met.
Okay.
So that way, in my case, I transited from excuse me. I transited from being an engineer to doing supply chain and now investment analysis. And it required a lot of relearning, right? Mastering of concepts, right? But I was able to do so because, as I said earlier, we are problem solvers. We are naturally trained to understand concepts before applying them, and that is what I did. So growth-wise, an engineer can grow to lead an organization, right? Because they understand both the technical aspects and at the later part of their career could then understand the non-technical aspect.
Okay.
Right?
Okay.
So engineers could become CEOs in the oil and gas industry.
Yeah.
Right?
Okay.
And so it's not an engineer has diverse paths.
It's very diverse.
Yeah, so you could become a specialist in your discipline.
Yeah.
In your discipline, or you could transit into something else and grow.
Yeah.
Or you could be involved in general management. And even become an executive.
Okay.
Where do I see myself in the future?
Yeah.
I'm learning. Learning continually. I'm an eternal learner.
Yes.
Always learning.
Yeah.
So I would say fingers crossed.
Yeah.
What I want to do is maximize the opportunity to learn. Help my company achieve its objective.
Okay.
And also build teams that will remember me for the positive impact that I made on them, helping them grow to become very efficient, productive, and also great individuals, going home happy, and not seeing work as a toxic environment.
Which is important.
Very
important.
So
great.
Yeah.
Thank you so much, Enemako. It has been an amazing time here, and I myself have gotten to understand some terms that I usually mistake over and over again. So thank you. And for anyone watching, if you are interested in the energy industry, like Enemako has said, there is no cause for alarm. If at all, we're going to have a mix. So your skill set is still important, because in that mix, that skill is required. However, you then need to be able to adapt to change and what technologies are being advanced, so that you are able to learn them quickly and use it or utilize it for whatever companies you are working on, even if it's for your own company as well. So yes, the sky is the limit, or is the starting point. And when you do get there, remember to pay your tithes to this channel, okay? Like I like to say. All right. So thank you guys for tuning in. Like I said, this is the season finale. And if there are any career paths that you would like us to explore further in season 2, please drop in the comment section, or you can send an email to upcomingwithjennifer@gmail.com, and we'll definitely respond. So thank you very much. Thank you. You want to say something?
Yeah, so I forgot to mention, or I just wanted to mention, for young people, for the young ones, those in secondary school or in the university, one of the ways to get into the industry will be to join the SPE, the Society for Petroleum Engineers.
Society for Petroleum Engineers. Okay.
There you have opportunity to volunteer. Also, you might have opportunity to intern. You can also get mentors who will guide you on your journey.
Good. Yeah.
I also recommend people applying for internships to at least test and see if they actually if the industry is actually where they want to be in the future, rather than work towards it without having experience.
Okay, so SPE, we'll put the link in the description box, or prioritize internships. If there's anything that all our speakers have said across all 8 episodes, is to prioritize internships, because even if you do not know where you're going to, it helps you to know what you don't even want to do in the first place, which is very important, right? So yeah, prioritize internships. And thank you again for joining us. See you on the next season.